Let's take a look at the formulas for hyperbola in standard form. And we want to first of all differentiate whether it's horizontal or vertical. And we're going to do that completely differently from the way we did for an ellipse. First of all, this equation is different from an ellipse, but very similar. The difference, and excuse the bad pun, is the difference sign. In a hyperbola, this is a subtraction sign. In an ellipse, this is an addition sign, and that's pretty much all that there is. That's the difference between the way the equations look like in standard form. However, the way we determine whether it's horizontal or vertical goes like this. We look at them and see which fraction is not being subtracted. So we have the fraction with the y term here being subtracted. The fraction with the x term is not being subtracted. And that determines which way the hyperbola is going to go. If the x term is not being subtracted, then our hyperbola is horizontal, just like the x-axis goes left and right. Our hyperbola is going to open left and right. A is going to be a little different also. It's not the square root of the large denominator like it is in an ellipse. It's the square root of the denominator from the fraction that is not being subtracted. Alright, A is the distance from the center to each vertex, but that's the transverse axis of symmetry, so A is halfway across our transverse axis of symmetry, the distance from the center to each vertex, and that's going to go left and right because this is horizontal hyperbola. B is going to go up and down to give us part of the conjugate axis of symmetry. They are not vertices, but they will help us draw a little box we'll show you about in a second. The center is HK, so the opposite of what's in parentheses with X, the opposite of what's in parentheses with Y. There are only 2 vertices for a hyperbola, whereas an ellipse has 4. We find them going left and right, A, so we're going to add A to the X value of the center and subtract A from the X value of the center. C, the distance from the center to each focus, well, that's going to go left and right also because this is a horizontal hyperbola. And this is different too. We're going to add the denominators together and then square root it. In an ellipse, remember, we subtracted large minus small denominator and square rooted. So we're adding them. To find the 2 foci, well, since this is a horizontal hyperbola and we're going left and right, we're going to add C to the x value of the vertex and subtract C from the x value of the center. I'm sorry, I meant the center, not the vertex. So HK is my center. It's going to be H plus C, and then it's going to be H minus C from the center, and the y value of the center is not going to change. Eccentricity of a hyperbola is calculated the same way as it is an ellipse. Eccentricity is C divided by A. However, the difference is hyperbola has eccentricities larger than 1. Now asymptotes, let's look at this graph for a minute. Here's the graph of a horizontal hyperbola. And I know you say they kind of look like parabolas, but they're not. But there are 2 branches, one that opens right, one that opens left for horizontal. We have the center. We went left A, we went right A to find the 2 vertices that I have in color blue. We went left C and right C to find the 2 foci, which I have colored in red. We went up B to this point and down B, this point from the center. Using A and B as the midpoints of sides, we're going to make a rectangle. That rectangle is not really part of my graph, but it'll help me shape my graph. If we take the diagonals of that rectangle and extend them out, those are called asymptotes. My hyperbola is going to go through the vertex, get closer and closer to the asymptote, never cross, never touch, never get parallel to. And so that helps define the shape of one branch and the other branch respectively. So we can find the asymptotes by going left and right A to find the 2 vertices, going up and down B, thinking of those 4 points as the midpoints of sides of a rectangle. Construct the rectangle. The diagonals are the asymptotes. We can also find the asymptotes by calculating their equations. Their equations for horizontal hyperbola is y equals plus or minus b over a distributed to x minus h plus k. Remember, b is the square root of the denominator that's being subtracted. A is the square root of the denominator not being subtracted. H, K are the values that tell us the center of our hyperbola. All right, let's look at a hyperbola that goes vertically. Vertically oriented hyperbola. Again, how we can tell is by looking at which fraction is not being subtracted. In this case, the fraction containing the x variable is being subtracted. Therefore, the variable containing the y, the fraction containing the y variable is not being subtracted. Since that is not being subtracted, then we're going to go up and down. We've got to open our hyperbola branches up and down. And quite often we will write the fraction that's not being subtracted first. All right, so if that y fraction is not being subtracted, hyperbola is vertical. A is going to be the square root of the denominator from that term, and that's going to give us the distance from the center to each of the two vertices. There's only two vertices, and that's also halfway across the transverse axis of symmetry. It's called transverse axis of symmetry because trans means across. It goes across the two vertices. B is the conjugate or the semi-conjugate axis. So that's the square root of the small number. And that's the distance. We're going to go up and down to find portions of that box. The center is still HK, but be careful. If we put the fraction that's not being subtracted first, don't just grab these numbers in the parentheses from left to right. H is the opposite of what's in parentheses with x. K is the opposite of what's in parentheses with y. And we're going to go up and down A from our center to find our vertices. So the x value does not change, but the y value is k plus a, k minus a. C is still the distance from the center to each focus, and C is still calculated as the sum of the denominators square rooted. To find the two foci, they're going to go up and down. So the x value of the center is not going to change, but we're going to add C to the y value of the center and subtract C from the y value of the center. Eccentricity is still C divided by A, and we should get a number larger than 1. Again, the equations for the asymptotes are going to be, in this case, just the reciprocal. Y is plus or minus a over b distributed to x minus h plus k. If it was horizontal, this was b over a. Vertical, it's a over b. And so as we look at this, here's our center. We went up a, down a to find our vertices. We went left b, right b to find 2 points that we're not going to really draw. But those and the vertices are going to be the midpoints of sides of a rectangle. We draw the diagonals of those rectangles and extend them outside of the rectangle. Those gives us the pictures of our asymptotes, which we can calculate. From the center, we go up C to find one focus, down C to find the other focus. The axis of symmetry that goes between the foci and the vertices is called the transverse axis. The other axis of symmetry is perpendicular to that, going through the center, and that's the conjugate axis. Now, one thing I want you to be careful of and watch out for, in these two examples, it just was coincidental. The way the rectangle is stretched is not always the way the hyperbola opens. So I know in this example, the hyperbola opens up and down, and this rectangle is stretched up and down. I know in the previous example, this hyperbola branch opened left and right, and my rectangle was stretched left and right. It is not always that way. The rectangle that guides us for the asymptotes can go the opposite direction of the hyperbola. If they go the same direction as the hyperbola, that'll give us narrower branches. If they go the opposite way of the hyperbola, that'll give us wider branches. So don't think that this little rectangle we use to draw the asymptotes has to be the same way as the branches of the hyperbola. Well, there's our formulas for hyperbolas in standard form, and we're going to dig in our next lesson and do some examples, and that should help you understand it.